Last thing on this problem right here, this is how your answers would be on your final. But if they asked in this directions, it said round to the nearest, I think it was 100th maybe. Let me just double check. Yeah, 100th if needed. So you can use whatever button you want, but it's just as quick for me to do this. Natural log of 3, close that, divided by the natural log of 4. Make sure you close that. Then put plus 1, so it would round to approximately 1.792. Oops, nope, it was to the hundredths, right? So let's try this. 1.79 tenths hundredths. Okay. Now, hopefully this will be the last video for this review. It's been quite a few of them. All right, so on this right here, our exponents are in, our variable is in our exponents. Now, there's two ways we can do this like we did the last one, but what I notice is I can write this with a power of 2, with a base of 2, not a power of 2. I can rewrite, I'm going to leave this 2 to the 3x plus 1, but I'm going to rewrite 4 as 2 to the second power, and that was raised to the 8th power. So what I did was I took out the 4 and replaced it with 2 to the second. Now, raising a power to a power, I multiply them. So on this side, I really have 2 to the 3x plus 1 on the left side. On the right side, I have 2 to the 16th. When we have the same base, and it says they're equal, that means in order for these to be equals, our exponents have to be equal. So what I can do is this implies that we can take 3x plus 1 and set it equal to 16. So I'm going to subtract the 1. You get 3x equals 15, because again I'm taking the 1 over here, so I subtract it. Divide by 3, and I get x equals 5. So to check this answer, I'm going to say 2 to the 3 times 5 plus 1, because I've got to make sure the left equals the right, just to double check, because some of these you don't have to check, but just to double check, just to make sure. This on the left hand side, this gives us 15, plus 1 is 16, and over here we have 4 to the 8th power. So we just take out our calculator. We're going to do 2 to the 16th, and again I could have done store just as easily, and 4 raised to the 8th power, and see how the left equals the right. So again, I could have stored this under x and then made sure that this equaled that. Okay, we're back to, we have our, again, we have e to the x power. That means I've got to get this all by itself first. So the first thing I'm going to do is I'm going to move the 4 over to the other side by adding 4 to both sides. That's going to get rid of that. Then I have 3e to the x power equals 64. I still have to get this by itself. It has a times 3, so we're going to divide by 3. Okay, so I have e to the x power equals 64 thirds. So to free up my exponent, I'm going to take the natural log of that. That's going to cancel that out, which leaves me with x. If I take the natural log there, I'm going to take the natural log here. The exact answer would be x equals, because again, this has a base e, so does that, so they cancel each other out. This gives us the natural log of 64 thirds. That would be the exact. Because the directions say round to the nearest hundredth, all you have to do is do natural log of 64 divided by 3. and we get approximately 3.06. Again, this is the exact answer. This is the approximate. Anytime you have to use your calculator and round, that's approximately. Okay, we're now on J. We're almost done. And I don't think K is on the answer sheet. Okay, right here, this side has a log, this side does not. So I'm going to use my circle of logs. When you see the common log, there's really the base 10 there, we just don't write it. So with the circle of logs, I'm going to say 10 to the second power equals x plus 3. So 10 to the second power equals my x plus 3. Now all I have to do is solve for x. This is the same thing as 100. When I take my 3 to the other side, I'm going to subtract it. So 100 minus 3 is going to give us 97 equals x. Again, you can check all of these. Like this one here, I didn't check that answer, but I had this. I'm going to store that under x. Now I'm going to plug in 3e to the x power minus, oops, I'm going to use my right arrow key, drop it down, minus 4. And if this answer right here is right, or this answer because it's rounded, it will give me 60. And it did. Right here, when I get 97, I'm going to try to put it where you guys can see it a little better. The light in here is killing it. So 97, store x. Let me bring that back up. Now I'm going to take the common log of x plus 3. Sorry, my husband's talking in the background. X plus 3, if you can hear it, and then I'm going to hit enter. If it is right, it's going to give me 2, and it did. Okay, now the last one. 2 of these have logs, the other one does not. Okay, so we've got to get all our logs on one side. So I'm going to bring this whole thing here, I'm going to bring it over to the other side. I'm going to do that by adding it. So I have log base 5 of w plus log base 5 of w minus 20 equals 3. Now, I'm going to condense these. I'm going to use my log, write it as a single log. So it's going to be log base 5, and multiplication goes with addition. So it's really saying w times w minus 20 equals 3. Now at this point, I can go ahead and do this, like distribute the w. It's fine. But what this is saying is I can do my circle of logs at this point. 5 to the third power is equal to that. So 5 to the third power equals my w times w minus 20. And at this point, I'm going to go ahead and distribute this. So 5 to the third power gives us 125 equals w squared minus 20w. Well, because I have a quadratic, I can do this. I can solve it by completing the square. I can solve it by quadratic. Hopefully it's going to factor, but in order to do quadratic or factor it, I got to set it equal to 0. So I'm going to bring this 125 over to the other side, and it's become a minus because I'm going to subtract it from both sides. So at this point I have 0 equals w squared minus 20w minus 125. Okay, this will factor as w minus 25 and w plus 5. I'm just making sure because I don't have this answer next to me. W squared 5w negative 25w, that gives me that negative 20w plus And then negative 25 times 5 gives us negative 125. Okay, so right here, my W equals 25. In this case, W equals negative 5. Now, you need to check both of these. Remember, we can't take logs of negative numbers. So the first thing I'm going to do is I'm going to say, okay, the 25 is okay, because when I plug in 25 here, that's positive. When I plug in 25 right here, I get 25 minus 20, which that's positive. So the only thing or up here, I'm sorry, the only thing I need to double check if I want, I mean, that was probably good enough for me, but to check it, okay, you are going to say 25 store X, and I'm going to hit my alpha F2, which is right here. The alpha button F2 will also bring up that log base. Okay, and it's going to be 5, and I'm going to put X right here. When I hit enter, I get 2, because 5 to the second power gives me 25. So that one's okay. Now I need to see if this side's going to give me 2. So I say 3 minus alpha F2 of number 5 again, and I'm going to put my 5 here, and I'm going to put X minus 20 right there. Again, this should give us 2, and it does. Okay, so this works. I know this one's not going to work, because when I plug it in here, I can't take, there's 5, no 5 to any exponent that's going to end up with a negative 5. But if you didn't see that, it has nothing to do with this answer can't be negative when we solve. It has to do when you plug it into here. So if I did negative 5 store X, watch what happens. Let's try, I'm trying to get it so that my lighting, okay, it's going to be right here. I'm going to bring that up. It's going to give me an error message, and that's because it's a non-real answer. So that alone won't work. Even if I say, okay, quit, if I plugged it into here, again, I'm going to get negative 5 minus 20, which is negative 25. It's still going to give me an error message, okay? So we are going to kick that out. And that is the that completes all the videos for the review for the final.